Thin layer chromatography, applications. In the previous webcasts, we discussed how TLC works and how to perform a TLC analysis. In this webcast, we will discuss what we can learn using TLC in the laboratory. One use of TLC is to do a preliminary determination of the purity of a compound. To do this kind of analysis, you will compare your sample of compound of unknown purity to a sample of the same compound that you know is pure. There are two possible results. Here on this TLC plate, I have two lanes, one labeled K and one labeled U. The lane labeled K is where I spotted my known pure sample of compound. The lane labeled U is where I spotted my compound of unknown purity. On this TLC plate, we can see that we have two spots in our unknown lane. Remember, each spot on the TLC plate corresponds to a different compound. Therefore, our sample of unknown purity is impure because it contains more than one compound. If our TLC instead looked like this, where we have only one spot in the unknown lane, and that one spot is at the same retention factor as the spot in the known purity lane, we can say that our sample of unknown purity is probably pure. Why am I saying probably? It is possible, albeit unlikely, to have an impurity with the same retention factor as the compound. In other words, it is possible that there are multiple spots overlapping together. Such a situation is unlikely, but it must always be considered. The next use of a TLC plate is a preliminary identification of an unknown compound. This analysis is very similar to the analysis we just used on the previous slide. We will do a comparison. We will spot a pure known compound and compare it to the spot of a pure unknown compound. One potential result is this TLC plate, where again K stands for our known compound and U stands for our unknown compound. Here, our unknown compound has a different retention factor than our known compound. Therefore, our unknown compound cannot be our known compound. We could also have a situation such as this, where our unknown compound has the same retention factor as our known compound. This is very good evidence that our unknown compound is the same as our known compound. However, it is possible that our unknown compound is a different compound that just happens to have the same retention factor as the known compound. This is unlikely, but it must always be considered. The final general use of TLC is following reaction progress. When a chemist performs an organic chemical reaction, how do they know when the reaction is done? We can use TLC to what we call monitor or watch a reaction as it proceeds. What we do is over time, we take the reaction solution and spot it on a TLC plate, which in this case designated by RXN for our reaction lane. And we compare our reaction lane to our starting material. This TLC plate corresponds to a TLC plate that was taken before the reaction began. As we can see, our reaction mixture contains only starting material. If we wait some amount of time, we might see a TLC plate that looks like this. We now see two spots in our reaction mixture. One spot corresponds to the starting material, but we also have this second new spot. This new spot probably belongs to the product we are making in this chemical reaction. If we wait even longer, we might see a TLC plate that looks like this. Our reaction mixture now contains only one spot again, but now that one spot does not correspond to the starting material. This means that all of our starting material is gone and has been converted to product. That brings us to the end of this webcast. To recap, TLC can be used to perform a preliminary purity analysis of a compound. Each spot on a TLC plate corresponds to a compound. If a single sample has more than one spot, that means that sample is impure. Remember, an analysis of a sample that shows only one spot does not mean that that compound is pure, definitively, but it is a good indication. TLC can be used to preliminarily identify an unknown compound. The retention factor for a compound is characteristic. Therefore, if the retention factor for an unknown compound matches the retention factor for a known compound, that is a good indication that the compounds are one and the same. Again, this is not definitive. It is possible that two compounds can be different but have the same retention factor. Finally, TLC can be used to monitor the progress of a reaction. If TLC analyses are performed over the course of a reaction, you may be able to see starting materials disappear and products appear on a TLC plate. When all starting material is gone, you know that all of your starting material has been consumed and the reaction is complete.